back to the greatest classic car database on the face of the earth. In this video, I'm going to be talking about a clutch. Clutch, flywheel, and pressure plate on a manual transmission car. So, as usual, another scientific approach, scientific video about the clutch. As usual, I start the videos based on problems that have occurred, and in my case, this will apply to the 1963 Rambler American behind me, light blue car, the baby blue, and the transmission, the clutch was slipping. How do I know it's slipping? Because basically the car did not move with the engine. So normally, the way I was driving it before, you put it in gear, the car takes off right away, and I could literally spin, I could literally burn rubber. I could literally spin tires and do some burnouts and donuts on a grass surface, or a stony road with big tires. So with the Rambler American, you're probably surprised, because it's not a very powerful car. It's not huge amounts of horsepower. By the way, horsepower and torque are different. The Rambler is a high torque car, not a high horsepower. They're different things. But in my case, the rear axle in the car has a very large gear, so it's got quite a bit of takeoff power, but not a lot of cruising highway speeds. It was designed for towing. It was an optional axle that came on my car. With that being said, the overdrive was essential. But anyways, I'm starting to diverge. What's happening is, like I said, the car, the engine will go very high RPMs, but the car would not move, or move very slowly. And I could feel it moving sometimes. It would stop and then get back to its normal speed. So that tells me that the clutch is slipping, because the way that the clutch works, it's two separate faces like that. So over here, on one of my hands is the flywheel, which is just a big round piece of round steel. On the other is the friction plate, which is connected to the transmission. So when they're separated, one can turn without the other. Okay. Then when they're pushed close together with a lot of force, they move together, and then therefore the engine, when they're separated, the engine can move without the car moving, and if they're together, the engine will move the transmission. Okay, so that allows you to, if you didn't have that, then the car would always move if the engine is on. So you wouldn't be able to stop the car without turning it off, which is not very good. So that's why there's a clutch, and that's really only for manual transmissions. Although the same principle applies to automatic transmissions. It's exactly the same thing, except there's various discs, various clutches, and different mechanisms. So, I'll show you what I mean. This is what a typical clutch looks like, and this is the actual clutch disc, and it's got friction material on it. This is the pressure plate, because it's the plate that exerts pressure. It really blew my mind, especially when I first started working with cars, to think that the whole force of the car is transmitted through pressure only, through 6 springs. So there's 2 here, 4 and 6. And just through force, like through pressure of friction alone, the whole force of the car is transmitted like that. There's no gears that are meshing together. It's just literally it's pushed on against each other, and they're able to move together. So it really is interesting. You understand what I'm saying? It's a lot of friction. It's just force. There's no gearing. It's actually teeth meshing into each other. It's just pressure, force of pressure from these springs. As you can imagine, they're really, really strong. So that's that. And if you watched my previous starting video, I knew the clutch. If it starts to slip like that, then you know there's either oil. That's very common. Sometimes oil will go on the friction material, and it'll leak from the engine or the transmission, and then it'll eliminate that friction. It'll create a smooth surface. And in this case, we want friction. We want as much friction as we can get. It is very windy. So, but in my case, there was no leaks, because when there are leaks, you can check for leaks and everything was dry, so I know there wasn't any leaks. So the only possible option is one of the either the clutch pressure plates or the clutch disc itself are broken or damaged somehow. So once again, this is a friction material, and it seems to me like this clutch disc has never been used. On the other hand, the clutch disc that was on my car, as you can see, it's shiny. It's very, very shiny. And when you look close to it, it's actually really pretty. It looks like marble or granite. It's something that you put in a house. And that, from what I understand, this is what's called burnt disc. It's not worn out. There's no, I mean, there could have been powder and material, but when I got the car, I already had both those clutch sets, so I'll show you in just a second. So when I got the car, when I got the Rambler, as you can see, there's two. There's on the left that's never been used by me. The one that was on it that I just removed is one on the right. So you never know, somebody might have removed it and cleaned it out, but it's not worn out. The reason I say it's not worn out is because the grooves are still deep. They're still quite deep. But because it's so smooth, the engine is not able to transmit its force to the transmission because it slips. So once again, in this case, it's just like brake pads. We don't want smooth brake pads. We want them to have quite a bit of friction holding power. With this here, there's no holding power whatsoever. And once again, the clutch, this one here, so you can see the difference. This one here literally looks like glass, like marble. It's very smooth and shiny. So it's not broken, it's just burnt. Which will lead us to my next discussion. Now, before I go into that, on the previous video I showed the video of me moving the clutch up and down, and it turns out that's normal. As you can see, there is a bit of movement on the supply female shaft here, and that's to allow easy reinstallation of the transmission. There's lots of movement there. That's that. Now, for the Rambler American, if you want to get really specific, this car is a 1963 Rambler American. T96 transmission. Some of them came with automatic transmissions called Flash-O-Matic, which from all that I know, it's the same as the Ford-O-Matic used on Ford cars. So I can literally pick up a transmission from Thunderbird and put it in a Rambler. I've never done it, so I'm not 100% certain, but it should be just a direct replacement. But in my case, I'm driving standard, and they all came with the T96, BorgWarner T96 manual transmission. And I have 3 of those transmissions, 2 of them with the overdrive, and 1 of them the original just 3-speed. And they all have a 1-inch diameter shaft, input shaft. The output shaft is different on 2 of them, but that's a whole different story. The Opes, and that's a different ball game. But the input shaft on all of them is 10 teeth and 1-inch diameter. So that's what I need for the clutch here. I've seen lots and lots of clutches, or clutch discs to be more specific, with 1 1/8 shaft diameter and 1 1/16 shaft diameter. They're very common. Fortunately, it's been a pain in the ass to try to locate a disc for a 1-inch diameter shaft. However, the 1 1/16 is a very small difference, so it should work. It should theoretically work. And the teeth, like I said, they're 10 teeth. But that's, we'll leave that for another video. I will try to see if I can use one of those common clutch discs. Now the other thing is, I don't know if you can notice it, but the one that looks like glass is slightly larger in diameter, the outer diameter, than the new one. So I'll put them back to back so you can see. So one is actually 8 inches diameter, the other one is 8.5. I'll show you the clutch plates, or pressure plates rather, and they're exactly the same. And if I put one on top of the other, they match perfectly. The only difference is the disc on one is slightly more narrow than the disc on the other. It's just that's it. And once again, similar to the clutch plate, the pressure plate disc here is also very, very smooth, but it's supposed to be smooth. Now, there are signs of discoloration and bluish marks. You probably won't be able to see that on the camera. And that are signs of overheating. When metal overheats, it changes to a bluish color. So that once again confirms to me that the clutch was burnt at some point, likely by the previous owner, or something like that. So I'll have to clean out this one, and that's the one that I'm going to be using. And okay, so now for part numbers. The larger the pressure plate is Borg in width. It's got a number here, 1587 type 887. There are numbers on the 3. See, nowadays they've got lots of levers. Back then it used to be, it says 75. Part number is the packet number. Smaller pressure, also 7520. Once again, I don't see a part number for it. disc, slightly larger, a half inch larger. I don't have a part number. I'll try to clean out the part number in a second of this smaller disc. I've been searching the internet for days trying to find this number. Heads up. 2324913-2. Once again, 23, 21, 91, 32. And it's just says NOS. That's part number for that. Now, with slightly different numbers, slightly different diameters, in terms of velocity, they're all the same. In terms of RPMs, it's all the same RPMs. But what changes is the position they're in. So, consider a big wheel that's spinning very rapidly. If you put your hand at the very center, let's say a grinder for example, there will be no rotation whatsoever. It's actually zero rotation. Sorry, it's the rotation is the same, but the velocity is zero. If you put your hand at the very center of the grinder, it will not hurt at all. Now, if you put your hand on the outside, velocity, it's spinning very fast. Everything's still spinning together. So if I give this clutch disc one turn, the outside has traveled maybe, I don't know, half a meter. The inside has only moved very small. So the actual distance traveled, or velocity, decreases from the outside towards the inside. So, if we put a very large clutch disc, it's going to be connected to the larger diameter of the flywheel. So, it's going to see more velocity. As soon as you let go of the clutch, it's going to be spinning the velocity where it contacts the flywheel is going to be very fast. Now, if we have a smaller clutch, like that, smaller diameter, and at the very center it's going to be slower. However, we have less torque. The larger the lever, the larger the torque we have. So it's basically what that means is it's a lot easier to burn the clutch with the larger diameter. However, you have more friction material. Regardless of the diameter, there's a lot of unused space on these clutches. So I've been thinking of designing my own clutch, but clutch disc. But I don't know. That's gonna have to be for some other day. So I just thought I'd clarify that. Basically, just to summarize, a burnt clutch and slightly different diameter. Larger diameter, you have more torque. It's able to transmit more torque, more response from the engine, but it's easier to burn because the velocity is higher. Smaller disc, you have less torque, less velocity. Harder to burn out. video, I'll be showing you guys what I had to do to remove the clutch on the Rambler American, and that will be next video.